This is the periodic table of elements. And today what we're going to talk about is periodicity. All right, let's start with atomic radii or atomic size. We're going to go ahead and talk about, so when we think about radius, right? You think about it in math, you think about the distance half across a circle. And so what ends up happening here is you end up having, this is the size of the atom. And the reason is if you took the radius and doubled it, you have the diameter, right? A couple of trends you're going to see with atomic radius. The first trend of which you are going to see is you are going to see that for groups, it increases as you go top to bottom. So top to bottom, it's going to increase. And likewise for periods, it's going to increase as you go from right to left. So let's look at that trend. Okay, so the red arrows that you see here demonstrate the trends. Again, so it goes from top to bottom, increasing, and from right to left. So the smallest element that exists is helium over here. The largest element that exists is francium, right? Because again, the trend is top to bottom, right to left. All right, the next trend let's talk about is electronegativity. By definition, electronegativity refers to the electron attracting power, meaning these are elements that want to gain electrons. So the trends of the groups are as follows. For the groups, we increase bottom to top, and the periods go from left to right. So if we looked at electronegativity versus atomic radius, this one is the exact opposite. Now, also, metals generally have a low electronegativity value. We'll talk about that in a second and why that is. Nonmetals have high electronegativity values. And again, we'll talk about that in just a moment. Okay, again, that trend for electronegativity is bottom to top, left to right, increasing. Now let me tell you why that's the case, okay? And let me tell you also one thing about this graph that's a little, or this chart that's a little bit off. So when you look at this group right here, right? This is the group 7 elements. They have 7 valence electrons. They're called the halogens, right? These guys right here, fluorine, chlorine, bromine, iodine, and astatine. So because these guys have 7 valence electrons, they are desperately looking to gain an electron. Well, electronegativity talks about the electron attracting power, right? Wanting to gain electrons. As such, it makes sense that these guys would want to gain electrons. However, let's look now over here now at these guys, right? This is group 1A. They have 1 valence electron. They are looking to lose electrons. So as such, these guys wouldn't be looking to attract electrons. They'd be looking to get rid of them. Therefore, electronegativity in the first group, 1A, the alkali metals, is really, really, really low. Whereas over here in 7, they're really, really high. Now, I should modify this arrow a little bit. And what I really should do is I should remove a portion of it. And the reason that I should remove a portion of it is, see this little part right here? Well, these guys are the noble gases, right? They have 8 valence electrons. So, are they looking to electronegativity attract electrons? No, right? They've already got 8. So what I would do if I was you guys is I would go in and I would erase that. So what I would do is I would come in here and see if I can. Nope. So I would get rid of this part right here and I would just make your arrow be right there. Because this group right here, again, the group 8s, they don't have an electronegativity value. Their electronegativity value is 0. They aren't looking to attract anything. All right, so ionization energy, the amount of energy needed to strip an electron off an atom. Note that this says in a gaseous state. So where are gases located? Well, those are your nonmetals, right? They're on the upper right-hand portion of the periodic table. So a couple of things you see here. Ionization energy increases bottom to top and left to right. Notice this is the exact same trend as electronegativity. Metals, again, are low. nonmetals are high, you're going to notice the exact same trends as electronegativity for ionization energy. The big thing you got to remember here is gaseous state, gaseous state, gaseous state. They're looking for electrons in that gaseous state. So the amount of energy you need to strip an electron, meaning if they want to just take one, well, they're going to do it. So again, ionization energy increases left to right and for the period and bottom to top. So bottom to top, left to right. Alrighty, and here is a chart, periodic table, showing you those trends again for increasing ionization energy. Bottom to top, left to right. Now, this one has that weird thing again where this one should not be included. So the arrow again should stop right here rather than going all the way through. Because, again, noble gases don't want to attract, don't want to strip electrons, etc., etc. They want to be left alone. These guys do want to strip off an electron. They've got 7 and they want one desperately. So therefore they have a high ionization energy. So again, the trend, bottom to top, left to right. And the last trend here, electron affinity, is the opposite of ionization energy. Instead of removing an electron from the element, we add an electron to create an anion. Now, one of the weird things with electron affinity is this in bold right here, that electroaffinity means more electrons. So becoming more negative in this case is good. Therefore, the trend of the group is still bottom to top, left to right. Bottom to top, left to right. And again, metals are high and nonmetals are low. I think actually that's the opposite of the other ones. Yeah, it is. So metals are high, nonmetals are low. But the trend, notice, is the same. Bottom to top, left to right. And that's because becoming more negative is good. And here's the trend again in graphic form. Again, bottom to top, left to right. Noble gases, no, they do not. So, again, just like previously, it would stop right here. Okay? And these guys, the noble gases, would indeed have no electron affinity. So, the trend, one more time, bottom to top, left to right, the same trend we've seen for electronegativity, ionization energy, and electron affinity. Alright, here are 4 review questions. Ranking the following by increasing atomic radius, rank the following by electronegativity, difference between electron affinity and ionization energy, and why would a person conclude that fluorine has a higher ionization energy than iodine. What I'd like you to do is press pause right now, go through these, rank them, and then after you hit play again, the answers will be